All right, the motion of a North Pole magnet. Okay, so this magnet's either approaching or receding. Okay, so let's do that first. Let's figure out the direction. Okay, let's figure out that the magnet has to approach to affect this current, right? Okay, so it's a North Pole magnet facing down, right? So here's the north, here's the south, right? Okay, and the current flows anti-clockwise. So anti-clockwise, here's this piece of paper, right? Anti-clockwise is like this, okay? So if you look at a loop and it's going anti-clockwise, it means it's going this direction, right? So wrap your fingers that way, right? And you'll see that a North Pole is, North Pole from above. Let's see, anti-clockwise. Whoops. You'll see that a North Pole is actually facing up. Okay, a North Pole is facing up and a South Pole is facing down. Okay, so you'll see that your thumb points up and your butt of your hand points down, right? Okay, so this thing is either approaching or receding, and the answer is that it must be approaching, right? Because the North Pole would oppose an approaching magnet, right? So the current opposes the magnet's motion. Okay, so I know that if it's presenting a North Pole, it must do so because the magnet's approaching, and that would oppose this motion. Okay, that's how I know. Okay, because this thing has to do work. The magnet does work. The magnet does work to oppose, to generate electrical energy. If it's doing work, it must be opposed. Okay. There we go. The magnet does work to oppose, to generate electrical energy. All right. So there's that. And now let's see. We want to know what is the area of the loop in square meters. All right. So we're trying to find that. So our EMF is going to be NBA over T. I'm pretty sure it's just one winding, right? Our EMF is going to be V is IR. I'm using Ohm's law there, right? So the voltage is 8.6 amps. What's our resistance? 0.93. 8.6 times 0.93. 7.998 volts is the voltage being generated, right? So let's go 7.998 volts, right, is one winding. The magnetic field changes by 4.2 Teslas. Our area, we don't know what the area is, right? That's what we're trying to find. And then the time is, do we have the time? Yes, 0.0210 seconds. All right, and that's volts. So I guess I'm going to take this guy and go times 0.021. Then I'm going to divide by 4.2. And I should have the area. I'm getting that the area is 0.03999 square meters, right? That's the answer. Now, of course, if it's, if L times L is equal to the area, right? It's a square. We could find the length of the sides by just square rooting. So raised to the 0.5. The sides, L is equal to 0.19997 meters, which is about 20 centimeters on a side. Okay, but this is all we had to do. This is all we had to put for our answer. So